20 to do.
Crewton Ramone's How's the Math?
.com.
Here's my favorite thing. We're gonna get the camera on too late. This boy did this problem in his head, so we're just doing some problems here. All these problems he can do without even having blocks now, right?
X squared.
So you got 9x and 20, and I asked him what the sides were, what the factors were, and he could do it. So let's do a quick one. Okay, no blocks, no symbols, no anything, just verbally, right? Pretending we're Pythagoreans. X squared plus 6x plus 9. What are the factors? But you, keep working on this one. You're working on this one. Okay, so this is the 5-year-old. He's working on x squared, 9x, and 20, factoring it. You gotta be able to put 20 in there.
What was the problem?
X squared and 6x and 9.
Okay.
What are the sides? Now put blocks in and see what you get. You were just talking about it.
1, 2, 3, 4, 5.
Right.
Okay.
How many 5s? Get some 5s and put it in there.
I need 4. 2.
What's 4 5s?
20.
Well then.
That's why I was taking X plus 3.
Which, very good. Which is what? Do I have to say it twice, or could I just say x plus 3 what?
X plus 3 times.
X plus 3 squared?
X plus 3 squared.
Right?
Yep.
What does that mean? It means it's x plus 3 both ways? Right. You'll notice that their shirts are inside out and backwards.
We did it just for fun.
I think it's fitting. They did it just for fun. But it's like this math is inside out and backwards. Right?
Yeah.
Because it's so foreign to teachers everywhere and a lot of parents. It's a 5-year-old and a 6-year-old doing algebra. How is this possible? Alright, so can you see?
Yep.
Alright, so he built it because he still needs. Well, what's just the edge? You're right. There's 4x here, but what's just the edge? Yeah, you need that, guys.
X plus 5.
Right, and what's this side?
X
what does that guy see?
plus 4.
There you go. So the factors are x plus 4 times x plus 5. Right? And see, look, they're kids. They play. That's what they're doing. So you should play math with your kids. I'm telling you directly. Alright. Pay attention. Let's try another one. X squared. Oh, let's try this one right here. And then here's the other thing. We're going to get to negatives. Right? So you won't see that here for free. But you want to see these kids doing ones that have negatives. Like, oh, I bet that's neat, but can it do negatives? Of course it can do negatives.
Yeah.
Of course we can do negative ones. Easy, right?
Easy peasy.
Alright. So, and then what do they learn? They learn addition and subtraction. They learn about negative numbers and integers all at once. Right? Teach it all at once. Alright, so let's keep this one nice and short and just say Crewton Ramone's.
CrewtonRamone'sHouseMath.com.
Great job. Okay, so there's the addendum. We're going to keep going. Right? We just want to make that first one short so people would be like, hey, if that was the first time they ever saw it, they'd be like, what the heck is this? These little kids are doing algebra. They've got their shirts on inside out and backwards. This is crazy. Right. X squared, 10x, and 25.
X squared and 25.
10x and 25. Okay.
10x.
You get to use blocks.
Me?
You just try to do it in your head. X squared, 10x, and 25. And like you'll see him like, if I could look down here, he's kind of fooling around on his hand, right? Anyway. Alright, try it. You need 10x, and you need 25.
5.
And see, I'm going to break it up for you because otherwise it'd be way too easy. Alright, so how many x do you have? You have 9, so how many more do you need if you want to have 10x?
That's 8x. 1.
Okay, good.
X plus 5 squared.
Very good. Right? Okay, so let's get crazy. Now we're going to get past 10. Last one. And
easy. That's going to be easy stuff.
Alright, it's going to be easy stuff, right?
Yes, okay. You're so good at math.
Okay, so now it just takes him some time to get the things out. You could, alright, fine, he's building it, he'll put it together. We'll get back to him in just a second. Now you, x squared, 11x, and 24. What are the factors? Think about it, 11x and 24. Now see, it's starting to get up past where he needs to know more multiplication to be able to solve these, right? But once they understand the multiplication, boom. Right, these become easy. What do you think it's going to be if it's 24?
X plus 4, X plus 6. Right? No, wait.
That would give me, X plus 4 would give me 24, you're right. But 6 and 4, how many X would that give me? That would only give me 10X. So good thinking, but I want 11X. So try again.
Easy.
Okay, and he has solved the other one, right? And you can see it's X plus 5 squared there, right? Easy, he's 5. He's 5 and it's easy. When it was 4, it was also easy, right? Where are these kids going to be compared to other kids? Alright, so, again, because, and I don't want to say anything because it'll give him the hint, because this is on a table, alright, or on a, these are multiplication facts that he does not have readily available, it's a little bit harder, which is why I gave him the challenge. Because he's right, 6 and 4 is 24, but that only would give me 10X. So 24, what other factors of 24 are there? How could you make a 24? You're right, 6 4s or 4 6s, but what else could you do? I'm not giving you any hints. So anyway, we'll turn it off and let him see if he gets it. Alright, not 100% in his head this time. Had to get out some blocks. But the only blocks we got out was to figure out the 24. Because he knew 6 and 4. What do you have there? What do you have? Put him in a rectangle. First he was thinking it was 7 3s because he lost track counting on his fingers. And again, see, he doesn't have the facts memorized out here this far yet, but it's coming. He's 6.
Yeah.
Alright, so then what? How many is that?
8 3s.
It's 8 3s.
3,
and we could count by 8 too, couldn't we?
15, 18.
Much faster. This is the reason why.
18, 16, 24.
18, 16, 24? What?
18, 16. 8.
Count for me by 3s.
20. No, 8, 16, 24.
Oh, you're counting by 8, 16, 24. I thought you were counting by 3s. You're correct. 8, 16, 24. Okay. Isn't that way faster than getting out all of those guys?
Yep.
Alright, now, do you think those are going to be the factors? Do you think it's going to add up to 11X? Okay, now in our minds, we're only looking at this one corner. So we just went super advanced for those guys that are watching. See, because people watch this and they're like, I don't understand what the heck it is you're doing. Because they can't see what we're looking at is this corner over here. So I'd have, in our imagination, how many X would be there?
11.
Oh, very good. Okay, I said how many here is how many?
How many there?
Yeah, just on this side.
3.
On this side would be 3. How many on this side?
8.
Okay. How many on this side?
3.
Which is?
11.
11X. So did you solve it?
Yep. Yeah.
Tell me the factors, please.
Oh wait. X plus 3. X plus 8.
Right. X plus 3 times X plus 8.
And mine
there you go.
Is
now,
X plus
5.
5 plus and X plus 5.
Very good. And we could say, what else could we say? When they're the same? We could say
X plus 5 squared.
Yep, there you go. Okay. If you want to see these, you need a password. It's as simple as that.
Yep.
Okay, and these will actually have to build so you can be able to follow along, right? Because that's how advanced these little kids are. It's like, do you need blocks? Because eventually, because I always hear the argument, oh, are they going to need to carry the blocks with them to school? No, they don't need to carry the blocks with them to school. Right? Where do you carry it? Where do you carry your blocks?
Nowhere. In our brain.
Right. Here, go like this. Point to your head. Right? This is where you carry your blocks. Right?
I take out my brain.
All right. There you go. So, and then we'll fool around with a few of these, and we're done.
And a box.
Yep. Okay.
Look, this guy's box on the head.
All right. Don't do that.